things on SQL queries. Right, so just wanted to go over a little bit about subqueries. Right, we mentioned already that we can nest queries inside of other queries by using parentheses where the output of the inner query can then be used as an input for the outer query. Right, so that and any field that is declared inside of the inner select statement, right, either with the as clause or any fields that are selected in the select clause of the inner field can then be referenced in the where clause, right, of the outer select statement, which is very, very powerful. So here, for instance, we are asking, select for me all the first names of the folks that are in the student details, but here notice that we're hard coding the names of the people, right? And but this doesn't work. It only works if these are the 3 students in the data set. But if if we have new students, this would not work, right? Instead, we can replace that with a more generic subquery, right? That would extract the list of all the students, right, in a particular course or a particular section, or matching a particular query, so this is definitely much more useful. Here we have another example where we're using an inner query to first identify all all the population for where the name of the country is Russia, and then we're using that in an outer query, right, to compare and extract the name of the name of the region where the population is greater than whatever we extracted, right? So this might come back with multiple values of population, right? And then we can query outside and aggregate that value up higher. So these queries that are internal, right, that are used as tables, right, as providing the input for data set for an outer query, are oftentimes referred to as an inline view because they behave exactly like a view. Ideally, we would replace this instead with a view itself, right, and then we would give it a name, right, and then we could use it here instead. Okay. Here's yet another subquery. Anyway, here's another syntax of being able to compute the union of 2 queries, which basically copies and pastes them together into a single result set, where this only would work if you have the same column names, right? So that it knows that the result set of one of the queries aligns perfectly with the result set of another. So for instance, here's two tables that happen to have exactly the same table names. But that's okay. It's okay if they don't have the table names, as long as you do the transformation that gives them the same name, right? Because you can always use as, right, to rename the column name. So anyway, so if we create the union of these 2, the default is to eliminate the any redundancy, right? If the same piece of data appears in both of the tables, it only keeps one of them, right? So Dole Stephen appears in both of them in the Canada employees and the USA employees, right? You only get one of the instances. Or you can ask that I want both of them, right? I don't care, right? I want both records from both places with union all, right? Do not filter the. We then have order by, which allows you to only for presentation purposes, display the data as in ascending or descending order. And you can give it any number of columns. It'll first order by one, and then the other, and group them by those column names. So you can order by last name. So here we have order by last name Boone. Now, if you have multiple columns, they only make sense if the previous column, right, has multiple instances of the same value, right? So if you have lots of Boones and lots of Doles and lots of Garcias and lots of Nielsen's, then ordering them by first name makes sense, right? But if you don't have any, any repetition in the previous columns, then ordering by a second or third column is meaningless, right? It only makes sense if the previous columns, right, the last names are repeating, right, and they create a group by which you can then sort within that group, right? You can go both ways, ascending or descending. Then self-join. So oftentimes you need to, obviously it's very common that you grab values from one table and you join it against values in another table where two fields are the same, right? That makes sense. But oftentimes you find yourself that you need to join tables within themselves, right? Especially if those tables are declaring a structure that is a kind of like a hierarchical structure, right? Where when it's not representing individual instances, but instances that are related to other instances in the same table, right? And imagine you have an employees table. Not all employees are the same, right? Right there is a natural hierarchy or natural structure of how employees organize themselves, right? Yes, we are all employees, but some employees report to other employees, right? There are managers. You have different folks have different roles, right? And so within the same employees table, there is structure, right? Just like we typically break out that structure into multiple tables, right? That sometimes you have structures within the same table, right? So self-joins allows you to deal with this, right? For this to work, you would need to have fields in the table that allow you to unwind the relationship or the structure within that table. Here we have a field called parent ID that if you notice, it's a foreign key, right? So meaning the values for that field are IDs that are declared in the first record. Here you have this field, right? You have this field ID. Well, parent ID, the values of parent ID are values of the field in the ID field. Okay, so you might have here a category that might have subcategories, right? So you might have electronics or entertainment as a super category, which under these you might have other subcategories, right? So this parent ID points to a higher category, and notice that we are telling you that it's the parent ID over here is referencing the same table category, right? But the field ID. So it's a foreign key that refers to the primary key of the same exact table. So examples are categories or employee and employee table will also create a hierarchy. So here we have an example of creating categories and subcategories. So we have the top the top category that has no parent. It has no parent. But here we have electronics, movies, PCs, DVDs. These are all categories, right? And they're all pointing to these are the two top categories, electronics and movies, right? And they have parent 1, which is the top one. And then you have PCs pointing to the electronics, right, as a parent category, whereas DVDs and Blu-rays are pointing to the movies over here. So you kind of have this hierarchy of top categories, then electronics and movies, and then under electronics you have PCs, and under movies you have DVDs and Blu-rays. So you can then kind of walk the hierarchy. You can walk the hierarchy by joining together, right, the parent IDs with the IDs, right, because they refer to one another, right? But for this to work, right, and notice that you have to, in the from clause, typically you have to provide the names of the tables that you're joining, right? But what do you do if the tables have the same name, right? You're joining the table with itself. What you can do is, typically you would have to say, from categories, comma, categories. So that's ambiguous, right? There's no way to uniquely refer to one or the other. So what you could do is you can name them. You can do, just like as, right? You can rename the tables so that you can locally refer to them, saying that, I want all the names of the categories where the child parent points to the parent ID, okay, and retrieve from me. And so this would create, a listing of all the, of a recursive. This would be a recursive iteration of all the categories and their parents, okay. So we could, where the parent name is movies. Okay, so then here is enumeration. Enumeration, and I believe in the assignment you're asked to implement enumerations, right? And so in SQL, there's a very simple. They can be implemented very, very simply by using the enum keyword. So enum allows you to create enumerated data types where you're saying that a particular value can only have these valid values, right? Now, obviously, all data types are enumerated, right? In one way or another. Integers are also enumerated data type, but they have a lot of enumerations, right? All the values from minus infinity, perhaps, all the way to plus infinity, but they're enumerated data type. And also dates, right? You have all the combinations of months, years, and days, and all those are the valid enumerated values for a date. But if you want to create a brand new type and you want to specify all the possible valid values for that type, then you can use enum and say, well, name can only have these three values, right, for the sizes, small, medium, and large. Now, the problem with using enum is that it's only supported by a subset of vendors, right? A subset of that support the keyword. So they're not migratable from one vendor to the next. Right? So I would ask that you don't use enum, right? Since it only works with a subset of vendors. So instead, I would ask you to use what are sometimes referred to as portable enums. So this is an implementation of enumerated data types that can be used, in any SQL, right? Any version of SQL. So what you could do is create a genre. So here's an example of using a genre for movies and or books, where you have different genres for comedy, drama, and horror. And so you can create a table where you have a name field that can hold a varchar, and that name is a primary key that refers to the to a particular. It's a primary key that holds the values, right? So these have to be unique because it's a primary key, and because it's a primary key, other tables can refer to it. So like a movie table can have a field called genre. You can call it any which way you want, but we can constrain it and say that the local genre field refers to, it's a foreign key that refers to the genre table. Right? So the only possible values for the genre field here because it's a foreign key that refers to a primary key, right? And the only values there were inserted. It can only possibly be comedy, drama, or horror. See that? So it's basically this genre, right? Field has the functionality of a enumerated data type, right? You cannot put any value there that is not listed here. Also, the benefit of this is that it's a table, right? And we can query it. We can say, give me the list of all the genres, for instance, right? Or maybe we could modify. We can update it. We can add to it. We can remove it. So it's a managed enumerated data type. So we could have a UI, right, that manages this or queries it, and we can use it to maybe populate a drop down, right, from where we can select the genre. So it's very, very convenient. Whereas the Enum wouldn't allow you to do that, right? It's a hard-coded list of values that cannot be modified or queried or in any way. So this is certainly for the assignment. I would ask you to use the portable enumerated data type implementation. Yes, and I think you have 2 enumerated data types in there. And for in UML you would represent it this way. So we have the movie genre field of type genre, which is referencing all the possible values in the enumeration genre. Okay, stereotype. So we model it using a stereotype called enumeration. All right.